Well, of course, the question I'm most often asked when people know I'm an astronomer is, are we alone? Is there life out there? The answer is, of course, we don't know, because I get letters from people who think they do know the answer. They've been abducted by aliens or visited them. And I say two things to these people. I say, first, do they really think that the aliens, having made the effort to come here, would meet a few well-known cranks, make a corner circle and go away again? And I tell them to write to each other and not to me. But I think it is an important question. I hope that we will answer that question in the next few decades. I think we will understand how life began here on Earth, and that will tell us whether it was a rare fluke or whether it would have happened elsewhere. And that would, of course, tell us whether simple life was widespread. But, of course, even when you've got simple life, it's not clear how likely it is that it surmounts all the various barriers that clearly life experienced in evolving from simple life to multicellular life to more complex land-based life, as happened here. All we can say as astronomers is that we know that there are, even in our galaxy, billions of planets rather like our Earth, on which, in principle, life could have evolved. And I hope we will eventually learn how much life there is out there, and if we're very lucky, detect evidence for intelligent life. Well, why does it matter? I suppose it matters a bit because our cosmic modesty would depend on whether we are unique in the galaxy or not. If life turns out not to exist, then we can be less cosmically modest, because then our fate affects not just us on Earth, but may make a difference to the future of the galaxy. And I say that because one thing which perhaps astronomers are more aware of than most other educated people is the immense future lying ahead. Most people who are aware of geology and Darwinism, they're happy with the idea that we're the outcome of 3 or 4 billion years of evolution, that the Earth is 4.5 billion years old. But I think even most educated people somehow feel that we humans are the culmination, the end point of all this. They don't realize, as all astronomers do, that the Earth is only halfway through its life, and the time lying ahead, before the sun flares up and dies, is as long as the time that's elapsed up till now. And therefore, the time for future evolution here on Earth and beyond is as long as the time that evolution has taken up till now. And of course, beyond the Earth, then the end of the sun may not be the end of things, and the universe may go on expanding forever. So we should not think of humans as being the culmination of evolution, but nonetheless, we are humans, so we care about humans, and we are almost certainly an important transition species, the first technological species, and perhaps the species that will trigger the crucial transition from organic to electronic intelligence and life. So our future is important. So that's something which I bring as an astronomer to concerns of a more practical relevance. And I have, for the last 10 or 15 years, been thinking and writing about long-term threats to us and the human species. And, of course, I'm not saying anything very original, I'm talking about familiar ideas, but I think it's important to divide these into two categories. There are the threats which stem from us having entered the Anthropocene, an era which is the first century in the 45 million centuries of the Earth's history, where human beings, one species, can determine the planet's fate. And that's because there are more of us. The population is now over 7 billion, destined to rise to 9 billion by mid-century, and we're each more demanding of energy and resources. And so we are collectively going to the limit of what Rockstrom calls planetary boundaries, where we are perhaps living in a way that does not allow the planet to sustain its biodiversity, etc., and where there may be constraints on resources and where we may be affecting the climate. So we are collectively having an impact on the planet. And this is, of course, something which leads to worries about the future of our environment and whether we can feed people, etc. But the second class of threats, which are really the downsides of all the wonderful new technologies we're having. The fact that these new technologies empower small groups of people and make our world more interconnected, which makes us more vulnerable in many senses. And I'm thinking here of misuse of biotech and, of course, the downsides of AI and cyber technology.
And pandemics too. Pandemics.
Yes, indeed. Yes, so, of course, natural pandemics can spread at the speed of jet aircraft. And incidentally, I think we are connected so that rumour and panic can spread at the speed of light. And that
including
that
financial.
Yes.
But could I just ask, when there are millions of planets in the galaxy, and it seems that none of them to this moment has sent us any signal?
Well, we haven't listened very hard. I think we can't really say that yet.
But we haven't discovered anyone.
We haven't, but there are programs to look. And I think if we detect anything artificial, like a sort of narrow band signal or an oddly pulsing signal, I suspect it's unlikely it'll be a decodable message. It may just be the malfunctioning or burping of some very advanced machine. But I think the key thing would be to detect something which is manifestly not natural.
Yes.
Because that would tell us that technology had existed somewhere else.
But some people say that since we have not found anyone else being a civilization of our nature, despite the great numbers,
Yes.
It indicates that perhaps the lifetime of civilizations is very short, and people would connect that to the kind of vulnerabilities you're talking about. How do you see that?
Yes, well, that is an argument, but I think we don't know anything about how the other civilizations would evolve. This is a famous argument attributed to the physicist Enrico Fermi. That argument is, why aren't the aliens here? And the point there is that there are many stars which are 1 or 2 billion years older than the Sun, which could have had planets around them, and life would have had a head start on those, and therefore you might think that the aliens would be here if their evolution is something which happens on many, many planets. So that is an argument against very widespread intelligent life, but a colleague of mine in England wrote a book with 75 arguments against the Fermi paradox. None of them are very strong arguments, but I think it's a debatable question how surprised we should be that there are no aliens who've manifestly been here. But I think nonetheless we should look for any kind of evidence for some artificial transmission from space, and we should also look for evidence in any other way. We should look for some sort of artifact in the solar system, like in the movie 2001, or something which indicates that some aliens have been here or sent some probes here. So I think all these bets are entirely open, and we'll know, I think, and I defer to biologists, about the origin of life and how likely that is. And that'll give us some clues, but that still won't answer the question of how likely it is that simple life evolves into something which we would call intelligent, and what the average speed for that evolution is, and also whether that intelligence would lead to the wish to transmit signals or to travel. I would personally bet that if we do detect anything, it will be something which is electronic rather than organic, and that's an obvious deduction from what's happened on Earth. I mean, if what happens elsewhere tracks what's happened on the Earth, then we've had 4 billion years of biological evolution or thereabouts, and then a few millennia of our kind of civilization, leading probably within a few more centuries to machines taking over, as it were, and then they will have billions of years. So the civilization on Earth dominated by beings like us is just a thin sliver of a a few millennia in a context of billions of years. And if there is any life or any planet out there where life has tracked what's happened here, then we'd be unlikely to be synchronized with it to the extent that we would catch it in this very short sliver of time when it's dominated by organic intelligence. Far more likely that it would be far ahead of us, and therefore what we would detect would be something which would be very different from anything organic, anything human.
Okay,
I
how do
have
you
a
see
footnote.
this?
I have a footnote on your search for extraterrestrial intelligence by looking for narrowband signals. So,
But that's just one channel.
but let's look at all the channels. So there's a very well developed information theory, which tells us that if you want to get information from A to B, and you have any kind of noise in between, if there's a limit called the Shannon limit. And it turns out that as you approach it, you get codes that are more and more indistinguishable from noise.
Yes, absolutely.
Which means that if there's a civilization advanced enough to be able to send us signals, it would be indistinguishable from noise, so we wouldn't see anything that could be identified as unnatural.
Well, I mean, it could be narrow band. It would not be evidence of a signal, but I think detecting any narrow band transmission would be...
Well, so how do we have cell phones? It uses spread spectrum, right? Which means that you don't use the narrow band. That's a very inefficient way of using the spectrum, radio spectrum. But we just don't know. Yes. But I'm just saying that just the absence of a signal doesn't mean it's not there. I fully agree with you that it would be unlikely that we would detect a signal that was not noise. But I think the only hope would be that we would detect something that didn't seem natural by the way it was pulsing. So interestingly, the first pulsar, when it was first observed, it was LGM, little green M.
That's right, yes.
Because they thought this might be a signal from another civilization.
Yes, that's right. But of course, the other thing people talk about is a byproduct of some technology. I mean, for instance, if they use laser propulsion, then we might see a laser beam sweeping through it. So it may be that we would see not any attempt to communicate.
That's an interesting thought.
But some byproduct of their energy generation or their energy use.
Another signature would be a Dyson sphere, which would be infrared signals.
That's right. Yes, that's where they try to use as much energy of their star and convert it into infrared. Yeah.
But one thing is detecting and modes of detection. The other thing is it likely that there's a lot of life? And would that life be likely to be advanced or civilized or technological?
That's what we just don't know.
We don't know.
How do biologists see that?
It's actually very interesting because maybe it's a sign of aging, but as I'm getting older, I'm becoming more and more pessimistic about two things, about origin of life and such. And even if life originates successfully, origin of this kind of technical civilization as such. And that is partly due to this experience, how I have been watching, the development of research in this field. First of all, please don't forget that half of the time of all the evolution of the Earth, biological evolution, which is roughly 3.5 billion years, half of that time was strictly prokaryotic, bacteria. Yeah. Right now, that's very close to 100%.
Small,
right?
Yeah.
So my prediction is, and that is testable in the long run, that if we find life elsewhere, it would be somewhat similar to what we know about bacteria. Now, whether life as such is common or not, my hunch today is that because of the many problems that you face in chemical organization is that you have to pass a certain complexity threshold, but also in a certain direction. And that direction comes, because it cannot come from anywhere else, that direction comes about by chance. So again, I would say that you will find many planets with complex chemistry, but it doesn't mean that it will be producing anything like life, because for that you need to surpass the threshold, after which it becomes robust and self-enhancing. That's my view at the moment. I could be wrong, but I'm
No,
not very optimistic
No,
about
I agree, and the jump to multicellular, of course, which took more than 2 billion years, is clearly not an easy one, and so there may be some that haven't made that transition.
I fear at the moment that's the case. However, I think it's intellectually very important to ponder about these questions because we are very much plagued by what people call Earth chauvinism. Yeah. And Earth chauvinism now has been defeated by planetary investigations.
Yes,
I mean, look at the solar system now. And look at what you used to think about, about the solar system 20 years ago. I think that our view has been broadened, and why it would be very important, despite what I say, to find examples of independently evolving life. That's an important thing. Mars would be a case which probably is not or wasn't. Europa might be because of biological descent. In a way, we have only one experiment here. Yes, yes. So therefore, it's extremely difficult to say, okay, what is it that is very contingent, what is a little bit contingent, what could be completely different. Therefore, we would like to have independent evidence.
Well, absolutely, and of course, at the moment, it's consistent to say that it's so difficult for life to get started that it's only happened once in the universe, and that's consistent. But if we found a form of life, say on Europa or Enceladus, which had clearly evolved independently, that would completely transform the argument, because if life can arise independently twice in one solar system, then we could straightforwardly conclude that it has arisen in 1 billion places in our galaxy.
What about panspermia? So Francis Crick has written this book.
Yes.
I'm not sure, I talked to him about it.
Was he serious?
Times. He was. It was an intellectual, kind of a foray into science fiction. But it's a serious issue that should be considered, which is that one way life may have gotten here is from outer space, seeded from, that virus-like entities that could be embedded in meteorites or something that shower down on our solar system. And if that's true, then maybe it could, if it was found on some of the other outer planets, it might be from the same source.
Yes, but it's still got to get started somewhere. In fact, Fred Hoyle used to also believe in panspermia, but he had a better reason for believing in it, because he thought we were in a steady-state universe, and therefore you could relegate the origin of life back to the infinite past in that universe. You gained a lot. Whereas we know that the universe is only 3 times as old as the Earth, and the oldest stars with heavy elements in them are only twice as old as the Earth. So panspermia doesn't gain you a great deal.
Not much time to get here.
Yeah,
right?
it doesn't gain you very much.
There is one thing, though, this is very important technically speaking. It's one thing that really points against this, because presumably if it was panspermic, then you would assume that there must have been a long period of evolution before that. Now, the so-called biological or molecular clock is not very accurate, but if you compare, for example, such basic things as the amino acid transfer RNA synthetases, those are the stewards who really know the genetic code, right? And they obviously descended from each other, right? I mean, there were paralogs produced and so on. Now, if you have an estimate for a divergence of them, certainly even with an inaccurate clock, you could say whether the divergence of this synthesis goes back to something like 3 billion years ago or 6 billion years ago. And it's definitely not 6 billion years. I mean, that we can say, right? So what I'm getting at is that it gives you a rough idea that indeed it originated within the lifetime of the Earth. That doesn't rule out that it came from elsewhere, but it rules out the idea that it was due to evolution that was twice as long. You see my point?
I see, yeah.
You don't need that hypothesis of panspermia, so to speak.
I don't know, but it makes it less likely as an explanation for ourselves.
So looking forward, all we can do is indirectly see traces of planets on other solar systems.
Yes.
We don't see the planets directly, not yet, but possibly in the next 20, 30 years, we will be able to see directly enough that we can get the spectra of those planets, and thereby maybe see traces of
Evidence of some sort of life, yes. And,
is this correct? Yeah.
That is correct, I think, with more powerful telescopes.
Yeah.
We could learn quite a bit. I mean, I like to say, suppose aliens were looking at the Earth with a big telescope, then even if it looked, in Carl Sagan's phrase, a pale blue dot, then they could learn quite a bit about it, because the shade of blue would be different depending on whether the Pacific Ocean was facing them or the landmass of Asia. So they could learn to a continent ocean, the length of the day, and something about the seasons and climate. And of course, from spectroscopy, they could learn something about the atmosphere, and maybe even something about the vegetation. And so that's not an impossible goal if we have big telescopes 20 years from now, and if there are some Earth-like planets within, say, 10 light years or so, which is again quite possible.
But given that there are planets, and you can see some kind of change in the atmosphere, more oxygen or something that would indicate some kind of life.
Yes.
What would then be our guess at this life evolving into more complicated life, and could we even make a qualified guess of would that form cooperation?
Well,
Stuff like that.
of course, it could be that it's just very simple life, which is rather like the Earth was 2 billion years ago. We could not see if there was oxygen in the atmosphere or not. That would tell us something. But I think the chance of finding evidence that there's a complex biosphere like that on the Earth would be low, unless it's so advanced it does send out evidence of something artificial, which, as I say, is unlikely to be a decodable message, but could be some manifestation of technology, energy generation, lasers, radio waves, or something like that.
Can I ask a question here, because it goes back to, you mentioned the Dyson sphere, and I mean, some people have put the question which relates to what I have raised, the planetary and solar technology, that if, you know, the universe were teeming with intelligent life, why don't we observe more miracles in the sky, right? So why don't we see that there are many things that we can't explain with ordinary knowledge, because that could have been, you know, to large-scale technology. And I think there is one example now. There is one star.
Well, there was one star, and this is incidentally one of the stars that was found from the Kepler data by an amateur, which had variations in its brightness, which were not consistent with just a planet transiting, and people don't know how to explain it very much, and it was a candidate. I wouldn't bet very much on it, but that was an interesting candidate. But I think you're quite right in saying that if we can imagine that there are some planets that have led to a much more advanced or more energy consuming civilization, or maybe not, we shouldn't call it civilization, but entity, then we might see evidence for it. And indeed, the fact that we don't see this evidence staring us in the face is something which is in a way surprising if intelligent life is widespread. So
when we are in the process now of creating the connectivity through electronic devices, internet, coming artificial intelligence, there's this question of how can one govern a world that is connected so deeply? How is it possible to govern in a world that isn't top-down, hierarchically organized as in the history? Will this mean stability, or will this mean destabilizing? This question was raised by Martin earlier, and I wonder, do we feel that we are approaching a more stable state in terms of a connected world, or a more destable state? Well, I'll just say, I think the answer is not obvious. I mean, something which probably you know more about was there was an interesting paper in Nature written by Bob May and Andy Haldane. Bob May, you know of. Andy Haldane is a
an economist at the Bank of England, this was really using Bob May's earlier work, which, as I understood it, showed that multi-species ecologies were not necessarily more stable than few species ecologies, contrary to common intuition. And of course, this led one to suspect that instabilities in the economic system could arise even if things look very complicated indeed. So insofar as that is true, then a very complex system that looks to consist of lots of independent parts may still be subject to cascades and instabilities. I'm trespassing on your grounds, but I don't know.
Could you help us here?
I don't know what you think about that.
I'm a big fan of Andy Halliday and Bob May, of course. I think there's two things, just to go beyond the concept of instability, there's a couple of things that really count with human beings. One is the possibility that if you start to examine our society worldwide, our societies worldwide, they depend on economies worldwide. Those economies in turn consist largely of technologies. Technologies could be fairly primitive, fishing boats, could be factories, it could be, for us, internet, etc. So what are the chances that somehow all our technologies start to collapse and we go back to where we were, say, in the Middle Ages or before that? That's what I would call true collapse, or that's one sort of collapse. Human beings might still be there, but it's like one of these apocalyptic scenarios. Somehow the internet goes down, the economy goes down, there's an awful lot of horrible destruction, including destruction of other human beings or other species. And then a small group of people, wherever scattered around, are left pretty much in the Stone Age or before, and they'd have to reconstruct. I don't know, and I think that that's one source of collapse, is where somehow there's enough disruption that it destroys the technologies. I notice, as I used to be a demographer, and if you look at mortality, it doesn't vary that much, even in wars. What really destroys a civilization is when its underlying means of support, its technologies, whether that's growing potatoes in Ireland, or when that collapses, the civilization pretty much goes down. If it's just a matter of waging traditional wars, you see some blips in mortality, but quickly you recover because the technology is there and you come back very fast. The other thing to think about is the real possibility of very severe pandemics. And as Martin was saying just a little earlier, we're interconnected now. If something breaks out in some part of the world, especially a pandemic that we haven't witnessed or seen or properly understood, that can spread very, very fast. So those make that question a little easier. I believe pessimistically, I'm afraid that there will always be disruptions, petty dictators, wars, and we seem to recover reasonably fast. Take the American Civil War, quite brutal, really destructive of young men, but 10 years later, America's back.
Well, that's because the women were still around and
Yes.
didn't need that many men to keep
You
things
don't need
going.
many men to.
I was struck by, Germany was defeated twice in a few decades, and each time bounced back. I was in Germany as early as 1962, working there, and it was more advanced than Britain when I got there, and that was about 17 years after the war. So my question then is, what would it take to destroy, if you like, the technological infrastructure on the planet? The answer is quite a bit. We have to be careful we're not too monocultural in terms of everybody's depending on the same few technologies. What would it take for a really major pandemic? I studied recently the 1918 pandemic, so-called Spanish flu, and nobody quite knows the statistics. Nobody went out and measured it, but there's reasonable evidence that up to 10% of the world's population were stricken and died. Now that's huge. We could conceivably have something worse than that.
How about the bubonic plague? What was the
Oh, the
there?
bubonic plague, that was worse. It varied from country to country and really from little town to little town. But if you look at Europe, in some places it was up to 50%. In other places it was almost bypassed and might have been 10% or not at all. And the reason, of course, was it was carried, there were various vectors, including human beings. But what's very interesting about plagues like the bubonic plague is that the economy is altered for hundreds of years afterwards. There have been studies of what happened in England, very, very good historical studies. People disappeared, like, I don't know, let's say a third of the population in England disappeared 1349 for 2 or 3 years after that. But by the 1500s, things hadn't fully recovered, and there was a scarcity of peasants or a scarcity of basic workers for a good 100 years after that. And that altered the balance of power between the very low-level peasant farming population and the people who had more sustenance. So pandemics are absolutely, if they're very severe, they have very severe consequences. Technological collapses, we've had a few of those, Easter Island or whatever, they're extraordinarily severe consequences. Beyond that, we seem to recover. Now, I'm not trying to be too cheerful about this.
Yes, but I think it will be different now for a number of reasons. First, I mean, obviously the fatalities will tend to be worse in the mega cities of the world, you know, Mumbai, Lagos and places like that. And perhaps the fact that everyone's got mobile phones would amplify the disaster by panic and rumour, although in principle it could be used to help. But I think there'd be real social disruption in advanced countries if the fatality rate got to even 1%. It's not like in Black Death. And that's because once the casualty rate was such that hospitals couldn't cope and people realised they weren't getting the kind of treatment which would in principle be available if the numbers were less, then there'll be real social breakdown.
This is actually happening right now in Venezuela.
Really?
Yeah, they're completely broken down their social system. The hospitals, they don't have any drugs, and it's not sterile anymore, and the people have no food. So this is, I guess, it's an experiment that's being done right now.
And expectations are higher than they were at the time of the Black Death, and that therefore means that social disruption is more acute, even if the death rate's lower.
What's changed at the moment is that there is a natural, just take one example, there's a natural corridor for migrating birds. It's from the Arctic, northeast Siberia, down to China, particular Guangdong province. There's a set of lakes down there. So birds migrate. When they go up to the Arctic, they're wading around in these shallow pools, and everything that's biological, all sorts of bacteria, viruses, are shared. Then they come back down. Now that's been going on for a long, long time. What's new is factory farming in Guangdong province, right next door to these wild bird populations. And the level of technology there is fairly high, but the level of hygiene for those farms is not high, and they're pretty well very similar genetically, the domestic birds. That can be passed. So what we're seeing, actually, just to add to your, this is a bit doom and gloom, but what we're seeing is it's not just jet airliners, of course, that are, you've something in Hong Kong one day and it's in Toronto the next day. That's absolutely true. But if you look at the bad pandemics, they trace usually from animal species to other animal species to humans. And certainly this is true for Ebola, if I have it right, comes from gorilla populations, I think, and this spreads in Africa. This has been true for AIDS, it's been true for many of these things. What is new is that we human beings are clustered together in cities, and we're clustered close to animals, very often herds of animals or flocks of animals that we're breeding ourselves. So the whole system, if you like, has got far more connected. Animals passing things to humans, occasionally going the other direction, maybe birds passing something to fruit bats, which pass them to whatever to humans. And the whole species has become much more interconnected. So to go back to Andy Haldane and Bob May, we have an interconnected, much more interconnected network. There's a theme in network science and complexity called percolation phenomena. And if a network isn't highly connected, then you can get one domino, if you like, these are connections, domino hits another one, and then there's nothing to hit. Once you get all the dominoes in various configurations, very dense together, something.
This is actually, I know a little bit about this. So there's actually a phase transition.
That's right.
Yes.
Which in physics happens when you have liquid to ice or something.
Yeah.
Or steam. And what's interesting is that the density, as you vary it gradually, there's sudden transition where
That's
suddenly it becomes, it's just like a wildfire, it just goes to the whole population. And so you have to be very careful.
I believe that in many ways we've reached that density because we're far closer to domestic animals in the last 10,000 years, and in particular the last couple of hundred years, than we were ever before. Population densities are rising, and then the rate at which there's human transmission is rising. So I can condense all this to saying, pandemically speaking, I believe we're less safe than we think. Well, we tend to think we're about as safe as we've been in the previous 50 years. We've had a few pandemics, but they're under control.
But we need to identify these new viruses on the pig farm, as it were.
Yes.
But in terms of infrastructure, we are a little more safe than we often think.
I don't know. And let me just say a word on that. There's a problem. The infrastructure, how we build and use our economy, the means that we're using for support are more and more and more sophisticated. That means they're more dependent on other sets of technologies. So something goes down, for example, we can build fishing boats, or we can have very fancy navigational systems, and we can find shoals or schools of fish quickly and easily. If some of those technologies start to go down, we would be back to a birch bark canoe type of era. Those are robust technologies, they're primitive technologies, but they're much harder to wipe out. I'm trying to think of a good analogy here. If you have a horse and cart your horse and cart's likely to do pretty well no matter what. If you have a terribly fancy Ferrari bangs up against a wall, you can't fix the Ferrari, but you can deal with the horse and cart.
If you have intelligence, it's likely to work for a long time. If you have artificial intelligence, it will be vulnerable.
Vulnerable in that sense, complication. I think if there's major trouble, the first thing to go is high, sophisticated, complicated arrangements.
So there's an interesting trade-off, which is exactly as you described it, which is between efficiency and robustness.
Yes, that's right.
And what's happened is that we've gone up as we've gone up the slope toward more efficiency, we're losing robustness. And there's an interesting, you can go from the Ferrari to the jet, right?
Yeah.
I mean, in terms of getting faster. And you can go beyond, the simple civilian jets to military jets. So it turns out that military jets can no longer be flown by human beings.
Yeah.
In the same way that you're controlling the ailerons and so forth, it has to be done by machines, and the reason is the reaction time. They're in an unstable region, and the reaction time isn't of the human isn't fast enough to control it. So all these automatic control systems are actually flying it, and the human gives a few nudges here and there to say, I want to go right or left. But without the electronics, the thing would fly, would fall from the sky literally, because they can't even glide. They're not designed to glide even. So and the question is, how far up that slope have we created these interconnections within our civilization?
There's a good lesson in this, and I'd love Tor to say, just step out of your organizational mode, but say a word about the Sirius in Greenland.
The Sirius patrol in northern Greenland,
Yeah.
where people on sledges patrol an area which is inaccessible to snowmobiles and other stuff, because there's no gasoline station up there, there's no repair of anything. So they rely entirely on old Inuit traditions of using ropes to put their sledge together and so on, because these are proven technologies that's been there for a very long time and which can be handled by an individual. If you take this microphone, probably huge as it is, probably no individual person on this planet could put that one thing together, because it's division of labor and many different people involved. So modern technologies, you need other people, you need an infrastructure. With old technologies, you just repair your sledge when it's broken in northern Greenland.
Yeah.
And that's...
So your robustness...
That's exactly the trade-off.
Things that are not that complicated tend to be much more robust. Things that are very complicated technologically tend to be highly efficient. And as you take a hit on the high efficiency, then you go way down the ladder. If people are starving, there's been a bad war, they'll be bartering. They'll be growing their own food.
Yes. And there's a separate related thing where it's a question of efficiency versus redundancy, and that's in just-in-time delivery, where
Supply chain.
something is built up from things from different countries, and one breakdown in one country can screw things up completely, and if there's not redundancy.
I would like to know, in biology, you must be very used to this problem also of efficiency and robustness. So how do you think about all this?
Okay, let me start at a phenomenon which is very interesting, and that's the following. If you look at how ecological system works and you make a model of it, the astonishing result is that from the mathematical point of view, chaos ought to be typical. Whereas if you look at real ecological systems, chaos is extremely hard to find. There are only a few well-documented cases in ecology. Now, how come? Now, one of the most important things is that it's not one bathtub where everybody is. These populations are spatially located with limited migration between them. So if you simulate this system, you will see that there will be many fluctuations, but there is basically zero chance that the whole population would start, to do this chaotic behavior, which is very dangerous for several reasons, because of extinctions happen, but they are local extinctions. And you will be immediately repopulated from a neighboring local population, which is out of phase with the neighbor. That's a very important lesson. I raise this issue because this is one of the reasons why we have, so to speak, global stability for many realized biological populations. And I'm raising this especially because I think what you find in the financial domain, I think is extremely dangerous, because with the globalization and the speed of transfer that basically you generate this one bathtub kind of thing, and therefore any perturbation can beat in synchrony practically, right? And I think that, so a footnote, I know that there have been ideas to prevent them. I mean, my idea was that you should artificially limit the rate of transfer. So, for example, depending on the situation, you can introduce a regulation. But if the central banks feel that there is something strange going on, okay, you could say, all right, from now on, for a week, if you transfer a large chunk of money from Japan to Australia, it cannot be put into the accounts for 2 days, right? So for 2 days it will be simply not there. Although you launch the transfer, but it cannot have. Okay, that's one thing. The other thing is that you introduce a taxation relative to the amount of money that you want to transfer internationally. And that would also, have a dampening effect. So that I'm learning from ecology. Now, let me finish, because the globalization stuff, you mentioned monocultures, and monocultures are extremely dangerous because monocultures are very prone to epidemics. There is one aspect of the globalization, another aspect that I am very worried about it, is the cultural monoculture that we are creating via the internet, right? So, if you have a major disaster, I think that potentially there is an asset in cultural diversity, because different cultures would react differently to this, let us say, to the same global problem. But if everybody with time will have exactly the same patterns of reaction, which means that with time you might have only one culture, right? Then there's a problem, because everybody will react in the same way, and I'm worried about that, right? So I don't know, it's enough now for me, but I think that these are important.
Your first thing there where you said transactions should be stopped, that's already built in a lot into the systems called circuit breakers, and major stock markets have that, where trading just stops and say, okay, it's like big fight going on, say, everybody out of the pub, we're just going to cool it. So that's already there. Maybe you say something, I'd love to hear what you have to say about the obverse of all of that, and that is when you get all these little bathtubs that aren't connected. For example, when the United States was either 13 colonies or maybe 25 states, or not that well connected except by wagon train or something, you get that number of possible experiments. Mm-hmm. We'll have this school system here, we'll have this type of system there. And thereby the society, by figuring out what works well in one state, can transfer to another. That's starting to disappear, and this is something you must be very familiar with ecologically.
Oh yes, I mean I think that is I think very dangerous. This is why I think, for example, that if it's very, in a way, has a certain timeliness. If we are discussing something like the European Union, I think what they should not regulate centrally is what exactly the education system looks like. I think it's absolutely detrimental, right? Because it is exactly this diversity of approach.
You can go too far. So in the U.S. we have 21,000 school districts.
Of course.
And what that means is that it's impossible it's almost impossible to get
Yeah.
even a small fraction to adopt new procedures that would be valuable. So there must be a balance in terms of how
I agree with you,
how monolithic.
but you know, Europe is suffering from a problem of the first kind that I mentioned, because we call it the Bologna system. The Bologna system for higher education. You may not have heard about it in your splendid isolation there, but you know, the Bologna system was kind of a centralized reform of higher education in Europe. And so it was a combination of two things: stupid decisions that were made compulsory for all the countries. Now this is, I think, what is absolutely detrimental, and we should not do that. I agree, there should be a balance, but this is definitely over the top.
But diversity is something that means stability. Richness means stability. Is that what you're saying from?
Well, the basis of biology is diversity. I mean, it's natural selection, and you have to have something for it to work on.
Mm-hmm.
And that's it's interesting. It makes it robust, doesn't it?
Exactly.
Because it really means that you also, regardless of what the challenge is, if the environment changes, that there is some small fraction that will survive and continue to evolve. In fact, you mentioned HIV. Well, you know, there's a small fraction of humans that are immune to it, and it's not immune in the sense that there's a missing, there's an allele which is, I think, the receptor for the HIV, which is missing from these individuals, and so they don't respond to it.
And even there is a subpopulation who have been asymptomatic now for decades, which means that they, in that sense, they are even resistant to it, although they have, you know, you measure the virus is definitely in their blood and nothing happens.
And I, you know, it could be that this is our reserve, our reservoir that we have gotten here. That's how we got here. You know, we wouldn't. I'm sure the Earth has gone through. You know, the biosphere has gone through enormous. I mean, the asteroid that wiped out many
So a major
species.
part of robustness is to have that diversity, where there are people or there's systems that know how to cope with something quite weird and strange. If we all, I don't know, became, if the planet cooled by 50 degrees Celsius overnight, there was a movie to that effect, we'd still have Inuit who might know how. I mean, this is a cartoon sort of example, but we'd have people and species that know how to cope under that. If you try to make everything the same as people were saying, highly efficient, but not so robust.
So that deals also with the connectivity issue, because some people argue that the internet allows us to be much more diverse and have many different people can have many different connections and find their pen pal across the planet. But other people would argue that interconnectivity means that everything becomes the same and there's no reservoir.
I mean, I think it does in principle allow groups with strange views to find a few soulmates across the world, and this could have good effects, could have bad effects, because although the internet should broaden the mind, it as a book by Cass Sustein and other books, we'd say how it sort of narrows the mind, because however crazy your views are, you can find someone who shares them, and all these cults can find other people, and you don't have to talk to your next door neighbour who is probably saner than you are.
Not only that, but recently now, you know, there is this wide discussion that you know, some of these internet-based companies are actually using algorithms that reinforce such behavior.
Yes.
Oh,
right?
yes.
Yeah, and I think that's really dangerous.
Yes.
You get the stuff that you used to get, right? So it's, of course, it's kind of a positive
Feedback.
Yeah, a positive
And so
feedback.
it basically enhances fans the flames.
You become more and more crazy because you will get the input that, you know, the other few crazy people, and then, you know, everybody thinks. No, I think that's a very dangerous thing. But there was one other thing I wanted to mention. I think that what I find extremely dangerous for our stability is when different kinds of instabilities form a cascade. I just read a grant application 2 days ago, in fact, here, a bunch of epidemiologists and ecologists came together in Stockholm not a long time ago. I wasn't there, but I was now informed the grant application that there are two interesting things that I didn't know. That for parasites, shifting hosts apparently is much more common than people thought. And many of the recent shifts in hosts for parasites seems to have been triggered by climate change. Now that's something that you don't like to hear. Okay?
So in shifting hosts is from species to
You jump to another host, and you are parasitizing another host.
Another individual or
another species.
Another species.
Okay. Now that, right? So that I think that is quite disastrous. Or when we didn't mention it yet, but I think it's a major problem, when this climate change, undermines, for example, the agriculture of a certain region, and that happened, by the way, in Syria, apparently. Mm-hmm. Then, that triggers many things, that triggers local war, and then it can trigger, as we are seeing it, mass migration, into Europe, for example. So when these things start to reinforce each other, then again, because of the positive feedback, even without an asteroid, you could end up in a situation as if you had been hit by one.
But that having been said, over the last, billion years, how many ice ages has the Earth gone through? Where, I'm not sure if it's 50 degrees centigrade, but, these cascades must have happened many times, and the species, that's part of why they are able to survive these parasites, because they can do that over and over again, right? So I think that may not be quite as doom and gloom as you think, in the sense that the system has survived many of these catastrophic events before.
The system has done, but the question is whether our civilization has been able to survive. It's very difficult to wipe out humans as such, right? But to actually tax the civilization in its immune reaction to the point that it gives up, that's another, I think.
And when we talk about civilization in ordinary language, it's all about something that started actually at the end of the last ice age.
Yes,
that's a good point.
So we are living here, and how robust are we?
And actually, you raised something very interesting, which is that we were actually this last period has been unusually warm compared to previous periods.
And unusually stable.
And unusually
the
stable.
origin of agriculture could not have happened before, the experts say, because the climate was too much fluctuating.
Right.
You needed that period of tranquility.
So we're not that much safer.
Yes.
Should we take a 5-minute break and come back and discuss aging and discuss distribution in society?
Yep.
Yeah.
Okay, so we take a 5-minute break.
Sure.